is increasing and decreasing. If you'll notice this graph here, obviously visually you can see it's decreasing, it's constant, it's increasing. I mean, that's visually easy to see. But logic would tell you then if you were to do a tangent line over here on this side of it, your tangent line slope would be negative, right? That makes sense. If you did a tangent line over here, your slope would likely be positive, right? And if you did a tangent line where it's constant, your slope would be 0. And so not only does the first derivative give you a slope of the tangent line, it starts to give you a picture of the graph. You start to see a picture of the graph by what is happening on that side of it with your first derivative. If your first derivative is negative at a point, you have a negative slope. So the graph is going down. If your first derivative is positive at a certain point, your graph is going up. If your first derivative is 0 at a certain point, your graph is constant or it's at a turn. And so you can actually start to see pictures of this graph as to what's happening, where is it turning, and which way is it going. All right, a little bit more than you could have done in something like pre-cal. So the first thing they do is they tell us this test for increasing and decreasing. Obviously, increasing is when y is going up when x is moving to the positive. Decreasing is when y is going down when x is moving to the positive. Left to right, pretty much. And constant is when y is not changing when x is going up. That's what all that definition means in lots of math verbiage. This theorem says you can test it by taking the first derivative. If your first derivative is positive, you can assume the graph is increasing there. If it's negative, you can assume it's decreasing. If it's equal, you can assume that it is constant. Okay, that's what this theorem says. So let's look at this example. Find the open intervals on which this function is increasing or decreasing. Well, what do you notice about it changing? Well, it's increasing, and then it goes to decreasing, and then it goes to increasing. In order to go from increasing to decreasing, it has to turn, right? And so if it turns, then you are going to have a critical number. That's what we just determined in the last section. That if it turns, you're at a critical number. And so if you want to figure out the intervals where this is happening, the first thing you're going to do is have to find these critical numbers. And once you find the critical numbers, then you're going to set up intervals between the critical numbers and test a point to see if the point gives you a positive or a negative. All right, so let's do that. So our first step, if they want us to find intervals of increasing or decreasing, the very first thing we're going to do is take the first derivative. We need to find our first derivative. Our first derivative here is going to be 3x squared minus 3x. That is my first derivative, okay? The next thing that we need to do here is find critical numbers. All right? Critical numbers are where it's either 0 or undefined. All right? 0 or undefined. This guy's never going to be undefined, right? He's continuous. So I just have to worry about where it's 0. So I'm going to factor that first derivative and set it equal to 0. I have two critical numbers. They are what?
1 and 0.
And so now I need to set up intervals. So now I'm going to set up intervals based on these two critical numbers. My intervals are going to start at negative infinity. And they're going to go to my lowest critical number, which is 0. And then I'm going to just walk up with intervals until I get to positive infinity. All right? So now I'm going to go from 0 to 1. And then I'm going to go from 1 to infinity. You will always have one more interval than you have critical numbers. Right? So I've set up these intervals. And the next thing I need to do here is test these intervals. So I am going to test the intervals and see if they are increasing, decreasing, or constant. Now here's the thing. If you found your critical numbers, you found all the places it was constant. So you never want to use your endpoints, because if I plug in a 0 to my first derivative or a 1 into my first derivative, I'm going to get 0. You know how I know that? That's how I found them, right? So never use your endpoints. Use a number within the interval. I always use the easiest number. So like from negative infinity to 0, I'm going to use negative 1. right? I'm not going to use like negative 47. That would be dumb, right? So, and at this point, unlike max and min, where we went back to our original equation to find our y's, we're actually going to plug these into our first derivative because we want to see, is our first derivative positive? That means it's increasing. If it's negative, it's decreasing. So that's what we're actually solving. So test in your derivative. So I'm going to take a number in this interval. So I'm going to test -1 in my first derivative. So 3 times -1 squared minus 3 times -1. What do I get there? 3 plus 3, right? I don't even actually care what the number is. Sometimes I won't even bother, like especially if it's big old fractions in a radical, like a rational equation, I'm going to be like, oh, the numerator will be positive, the denominator will be negative, so it's going to be negative, right? I don't even go through the process of seeing what it's going to be if I can do it quickly in my head. It doesn't matter that it's 6. It actually matters that it's positive 6, okay? So I really only care that it is positive. This tells me that on this interval, my graph is increasing. That's what that tells me. All right, let's look at the next one. From 0 to 1, well, there is no pretty one we can use, so we're just going to use like 1/2, all right? 3 times 1/2 squared minus 3 times 1/2. 1/2 squared is going to be 1/4, so I'm going to have 3/4 minus 3/2. Which is bigger, 3/4 or 3/2? 3/2, so this is going to be negative. You see how I didn't even bother to figure out the common denominator and what it actually was? Not that that would have been a difficult one, but all I care about is it positive or negative? That one's negative. So on this one, this guy is decreasing.
So this will be when it goes up.
But we won't have the graph. All right, the last interval I'm going to test is this guy. So I'm just going to put a 2 here. 3 times 2 squared minus 3 times 2, which is going to be bigger. 3 times the 2 squared. So a bigger number minus a smaller number is going to be positive. This guy is increasing.
So like on a quiz or test, if we just
Basically, they just gave you the steps that I wrote out when we were doing that here. Locate the critical numbers. Use these numbers to test the intervals. Determine the sign of the value within that interval. Use that theorem to determine at that point, is it increasing or decreasing? All right? And you can see they did negative infinity and then whatever to infinity, etc. You can actually have a graph that doesn't turn. And so then you can test your first derivative across the whole graph to see if it's constantly going up or constantly going down, right? So that can happen as well. So when we did in this prior section, we determined if something was a max or a min based on just plugging it back into my original equation. And we were like, oh, well, the highest y value is a max, the lowest y value is a min, right? Those are really what you're talking about, absolutes within an interval, right? But you can determine your relative max and min by using first derivative all the time. Because here's the thing, just like on this graph that we looked at, clearly, if you go from increasing to decreasing, and it is a continuous graph, you had to have a relative max. That's the only way that can happen. You had to go up to a certain point, stop, turn, and go back down, which means you're going to have a peak here. If you go from decreasing back to increasing, you have to have a valley. That's the only way that happens. If you've ever been on a roller coaster, you can't be going up a hill and go down a hill without turning at some point, right? And that turn is going to be a peak. And so this is another way to say, well, this has to be a relative max. This has to be a relative min, because on a continuous function, I went from increasing to decreasing. So I had to turn at some peak, which means that peak is a relative max. And so instead of taking it and plugging it back in to your original function, you can see, do I have any relatives? Now, here's the thing. Absolutes, you need to figure out what the highest y value is and what the lowest y value is. But as far as your relatives, you can have relative max and mins, and you can have several of them because it's over the life of the graph versus a specific interval, okay? And so these increasing and decreasing can tell you, do I have a relative max or min? So it says, let C be a critical number on the function that's continuous. It has to be continuous here because you could go from increasing to decreasing and jump over. So if you had a vertical asymptote, you could be increasing and then you could go to decreasing and you actually don't have a relative max because you actually jumped over where you would normally turn. You had an asymptote, right? So that's why this has to be continuous. It has to be continuous to determine that there is a hump in the graph and not just I went from increasing, I had a vertical asymptote, and then I went decreasing after that, right? That would not be a relative max. That's actually not even on the graph where you actually change direction. But if it's continuous, it says, if it changes from negative to positive, then it's a relative min. If it changes from positive to negative, it's a relative max. If it doesn't change, then it is neither a max nor a min. That makes sense, okay? So like this guy right here, like your x cubed graphs. Your x cubed graphs technically don't have a max or min because they're continuously going up, right? And so there are going to be some situations where it doesn't change. So let's look at this. Find the relative extreme. So our first question said find increasing and decreasing intervals. This one says find your relative extrema. You are going to do the same exact process that you did to find your intervals. You're going to take first derivative, find your critical numbers, set up intervals on those critical numbers. If it goes from increasing to decreasing, you're going to figure that out. And then you're going to say, oh, it went from increasing to decreasing here. That's a relative max. It went from decreasing to increasing. That's a relative min. Okay? So we're going to do the same exact thing. We are going to do our first derivative. My first derivative here is going to be 1/2. What's the derivative of sine? Cosine of x. All right. We are going to set that equal to 0. So subtract 1/2, divide by -1. So where does your cosine equal 1/2? Well, cosine equals 1/2 at your 60-degree angles, or pi over 3s, right? Positive 1/2. There's two places on the graph if you're going the entire unit circle. X is positive in the first and the fourth quadrant, right? So at pi over 3, sorry, my 60-degree angles, pi over 3. And then the one that is below the axis, which is 5 pi over 3, right? Those are my two places that I have a 1/2 as my cosine, all right? So then I need to set up intervals on these particular ones. So I'm going to go, now here we're not going from negative infinity to positive infinity. They gave me an interval. It's just one unit circle, one circle. So I'm going to go from 0 to pi over 3. I'm going to go from pi over 3 to 5 pi over 3. And then I'm going to go from 5 pi over 3 to 2 pi. Okay. All right. So 0 to pi over 3. They chose pi over 4. Pi over 4 is a nice, so when I think about, you know, when I went from negative infinity to 0, I did -1 because I'm like, that's an easy number to put in. Why would pi over 4 be an easy guy to throw in there? What's my sine and cosine of pi over 4? Square root of 2 over 2 for both of them, right? And so it's an easy one. If you can grab a pi over 4, he's kind of an easy one to see. So they chose pi over 4, which is the logic there is it makes sense. So I'm going to say 1/2 minus, remember I'm plugging it back into my derivative, the cosine of pi over 4. All right. And I just need to know if it's going to be positive or negative. So cosine of pi over 4 is square root of 2 over 2. So 1 over 2 minus the square root of 2 over 2. Which one's bigger, 1 or the square root of 2? What's 1 is the square root of 1, right? So you have the square root of 1 minus the square root of 2. Yeah, so this is going to be a negative number. This guy is going to be negative. So right here, we're going to be decreasing, right? Make sense? Now from pi over 3 all the way around to 5 pi over 3, my easiest one to use is going to be pi because it's either 0 or 1, sine and cosine, right? So they did pi, which is what I would also do here. 1/2 minus the cosine of pi. All right. What's the cosine of pi? It's -1, right? So 1/2 minus a -1 is 1/2 plus 1. So this is going to be positive. So this guy is increasing, right? And then from 5 pi over 3 to 2 pi, they actually did a 7 pi over 4. And this is actually going to be the same exact cosine as pi over 4, right? I mean, you're same exact cosine because you're in first and fourth quadrant. So this guy is also going to be negative. He's going to be decreasing. This is a continuous function. We don't have anything that makes him a discontinuous for cosine. All right. So since this is continuous, it goes from decreasing to increasing, right, to decreasing. So this guy is going to be a valley, right? He's going to be a relative min. So I have a relative min at this point right here where it changes, pi over 3. This guy goes from increasing, right, to decreasing. Increasing to decreasing. So he is going to be a peak, or he's going to be a relative max. And if you look at the graph of this guy, you know there are little waves, right? You can see, yep, I went from decreasing to increasing right here, min. I went from increasing to decreasing, max. All right, this is a chain rule, right? So my first thing I'm going to do here is I'm going to find my first derivative, multiply by that 2/3, then x squared minus 4 to the -1/3, and then multiply by the derivative of the inside, which is just 2x, okay? So in the numerator, I have the 2x and the 2, which means I have 4x. In the denominator, I have the 3 and the x squared minus 4 to the 1/3, or the cubed root, okay? So here we need to figure out critical numbers. Critical numbers are either what makes it 0 or what makes it undefined. So I have one thing that makes it 0. What makes my numerator 0? Just 0. What makes my denominator undefined? Well, anything that makes it 0. So this guy is going to be either 2 or -2, right? Yes? Positive or -2. Set up intervals from -infinity to my lowest one. Then I'm just going to walk up, -2 to 0, 0 to 2, and 2 to infinity. Okay? Now here's the thing. Here's where I'm going to be like, let's just figure out if it's positive or negative. All right? So for this guy, this first one, -infinity to -2. Let's say I chose a -3. If I chose something like that, my numerator with a negative number is going to be negative, correct? All right? So negative on the numerator. My denominator, if I choose something less than the 2 that makes it 0, I'm going to square it, positive number, bigger than 4, right? To the 1/3. Still going to be positive. I don't actually care what it is. It's going to be positive. So this whole entire interval is going to be negative. Or you can write decreasing. All right, let's look at this guy. Let's say I chose something like a -1. All right, my numerator is going to be negative, right? Now I have a -1 squared minus 4. That's negative. The cubed root of a negative number is going to be negative. Times that 3, still going to be negative, right? So my denominator is going to be negative, which means the whole thing will be positive. That's increasing. All right. +1. Well, if I put a +1 in the numerator, it's going to be positive. But a +1 in the denominator is still going to be negative. 1 minus 4 is going to be -3. I don't really care what the square root of -3 is. I just know it's negative. This whole thing is going to be negative, decreasing. And then what happens over here if I choose something like 3? Same thing's going to happen, except it's going to be positive. Positive in the numerator, positive in the denominator. This guy is going to be increasing. So what happens? I have some extremes. I went from decreasing to increasing. What is -2? From decreasing to increasing, relative max or min? Decreasing to increasing. He's a valley, right? Min. Then I went from increasing to decreasing. What is 0 going to be? Relative max. He's going to be a peak. And then I went from decreasing to increasing. What is 2 going to be? It's another min. Does everybody see what's happening? We're creating a picture of the graph. All right. And you can see I draw these little guys here. That gives me a mental and physical picture now of whether I have a peak or a valley.